So for this problem here, find R and T given that the angle, remember this is the view from this side, is 21 degrees, and this is the view from that end, is 28 degrees. Find R, which is your angle of rotation up in this corner, and T, which is your angle of tilt within that. Okay, so if we start here, let's just pick this to be 10 millimeters, right? Or did you guys pick a length? All right, I'm going to use 10 just because it's easier. So I'm going to find this length and this length off of that, right? On this side, it's going to be tangent of 21 degrees equals 10 over, I'm going to call this x and this y. So 10 over x. So I make it over 1 times 10 is 10 divided by tangent of 21. 26.05. Over here, this one's going to be tangent of 28 degrees equals 10 over y. So 10 divided by tangent 28. You're right, 18.81. So when I'm looking up here, if I look at this triangle on the top here, right? That's where I'm going to start. That triangle looks like this. Here's R. 2605 and 1881. So R here is going to be the inverse tangent of 1881 divided by 2605. So 35.83 degrees. Now that we have that, we need to find this across here, right? So that's a new triangle. That's just a piece of this one. Here's our right angle. This is 26.05, and this is 35.83 degrees. To find this here, I'll call it Z. That's going to be a sine of 35.83 degrees equals Z over 26.05. Cross multiply and divide, it's going to be 26.05 times the sine of that 35, 15.25 millimeters. So then now T actually comes off the bottom of this, right? Off of this. So T is this angle here, where this is the 15.25. And this is just the 10 that we chose before. So T becomes the inverse tangent of 10 divided by 15.25. So second tangent 10 divided by the previous answer. 33.25 degrees. What do you think? Good deal. Yep. So that's when you have that just trying to mill a corner off of a piece.
Yeah, I just didn't see any Z would be having height of that.
Yeah. The Z is from here to here across that. This here up and down is what we chose, the 10 that we chose. Okay.
I just didn't see the 35.83 degrees.
Sure. Today what we're going to do is we're going to take a block that we've milled the edge off of it in both directions. I actually have one of those back here, I think. Oh, yes, I do.
But the back side isn't milled.
So it's going to look like this. You can see here's our block. We milled this edge off at this angle, and we milled this edge off at that angle. Yes, the other two sides are flat. And so now what we're looking at is what is the length of this edge and the angle at which that edge goes. And again, we're looking at, okay, let's rotate it so that that edge is up here, and then tilt it so that edge is flat. So we're just basically trying to find the orientation of that edge. So what we're going to do, let's say that we're looking at this thing from dead on top. From straight on top, it's going to look something like this, right? Our angle of rotation is going to be this angle right here. So if we're looking at this, let's say that this is the shadow down from this point. Right there, is that right angle? This is R. Now T, this is like if you take this line and you go straight down below it. So yes, this is the edge. It's right down here, right below it. So R is laying flat, T is going up and down. Does that make sense? No?
R is flat. Yeah.
Yeah, so here's your...
Yeah, but what you're doing is you're taking that wedge and
Yeah.
slicing it out.
Yeah.
Okay.
I'm just taping it, yeah, right, there's that wedge. I'm just taking a shot right straight down through it. R is the angle between that slice and the edge of the block, and T is the angle between flat and up to the edge. The angle within the slice. Yep. Well, let's give you some dimensions. Let's say that this here is 50 millimeters, 40 millimeters. Let's put this at 20 and 20. So what I'm really interested in is just this piece here, the part that contains that angled edge. What's this dimension here going to be? 30, right? 50 minus 20, and this is going to be 20. 40 minus 20. So R is pretty simple to find right now. R is simply going to be the inverse tangent of 20 over 30. Because here's 20, here's 30. We're looking at it strictly from, the horizontal projection of it. Excuse me, 33.69 degrees. T is a little bit more difficult to find. To find T, I'm going to have to know, let's say I tell you that this is 15 millimeters and the overall height is 40 millimeters.
Now your red dash line, are you on the back corner? Is that your the back lower corner?
Yeah, exactly. That's like going across the bottom of the...
But not all the way down.
Yeah,
You're coming all the way down to
this edge here. Yeah. It's like if I just take this cutout right here down to here, and I cut that out. Yep. That's corner to corner across the bottom of the box, if you're going to think of it that way. Basically what we're doing here is exactly the angle, corner to corner angular drilling. It's exactly what it is.
yeah, it's just.
Yeah.
And are you saying the total height is 55?
Nope, total height
Is
40. So that means the height of the, from here up, this height here is actually 25. So that means for T now, we got to find the length of that surface. The length of the surface is going to be the square root of 25 squared plus 20 squared plus 30 squared, right? You got 20, 30, and 25. 20, 30, and 25. If I cut out just this piece here and make it into a box,
Why wouldn't you just find the hypotenuse of
the bottom, like
this blue square you got right
you could have, and that would have given us the dimension across the bottom.
there? That's what I would have done.
Yeah. But I asked for the length of that edge. So we got to get that length anyway. So we're just taking the length of the edge.
I would just calculate the hypotenuse with those.
2.
Yeah.
And then use that again. Yeah, we can just do all 3 of them together at once. So remember we did that last week. You could do it that way. It just saves a little work to do them all 3 at once. $43.87, you got her. So then for T, it's going to be that the inverse sine of that 25, the height we had over here, over the hypotenuse of 43.87. If you did the bottom, it would be an inverse tangent because you had the 2 legs. So that comes out to be 34.74 degrees. What do you think? Doable? In your packet, 416 to 418, 1 through 13 the odds. This is your last homework assignment for the year.